Chapter 6, Number 3. A 1.8 kilogram block slides on a horizontal surface with a speed of v equals 0.8 meters per second and an acceleration of a equals 2.8 meters per second squared, as shown in the figure. A, what is the coefficient of kinetic friction between the block and the surface? And B, when the speed of this block slows down to 0.40 meters per second, is the magnitude of the acceleration greater than, less than, or equal to 2.8 meters per second squared? And explain. I'm going to do part B first because it's actually really easy. The acceleration will be the same because the kinetic friction doesn't depend on the velocity. As long as the object's moving, it's the same force of friction. In fact, let's draw our free body diagram over here, and we say that we have some various forces. We have the weight pulling down. We have a normal force pushing up, of course. And then here we have a force of friction pushing to the left, and that's it. We have the thing from gravity, and we have all the forces from the surface, and nothing else is in contact. So if we look at this, we can say that the sum of the forces in the x direction is just minus F sub f. And the sum of the forces in the y direction is Fn minus Fg. That's coming from the diagram, and we're using the fact that F points opposite to the usual convention. It's pointing this way when we usually have x positive that way and the direction's moving. And that we have a difference in sign between Fn and Fg because they are in different directions. Then from second law, we would have the sum of the forces in the x direction is the mass times minus a, and the sum of the forces in the vertical direction is the mass times 0, which of course is just 0. Putting those together, we have minus Ff equals m times minus a, and Fn minus Fg equals 0. We would probably turn these into Ff equals ma, and Fn equals Fg, which is m times g. And then we go a little further and say, well, mu sub k is the ratio of the frictional force over the normal force. So it's ma over mg, or just a over g, meaning we have a really quick accelerometer in some sense. And here we get 2.8 meters per second squared over 9.81 meters per second squared, which is 0.285. And that's what we have. Well, we only have 2 digits of sig figs for A, so we only really get 2 sig figs here. 0.29 is our coefficient of kinetic friction. And then we can see again, A depends only on G and mu, and won't be any different no matter how fast the block is going until the moment it actually stops.